Okay, question 1. A shape is translated by the vector 0, 4. In which direction does the shape move? Up, down, left or right? Okay, so the top bit of the vector is talking about the x-coordinate, the bottom part is talking about the y-coordinate. So we know this vector is going to move 4 directions positive in the y-axis. So we've got x, y, and it's moving 4 up on the y. So this vector is moving up. Question 2. What is 1.75 kilometers as a fraction of 700 meters? Circle your answer. Okay, what we need to do here is notice that we've got meters and kilometers. So we've got kilometers and meters. So all we need to do is convert this into meters. So we're going to do 1,750 over 700 meters. And this is going to simplify down to 5 over 2. And that's your answer. The first 4 terms of a linear sequence are 3, 11, 19 and 27. Circle the expression for the nth term. Okay, so it's a linear sequence, so we want to find out the difference between each one. So each time you're adding 8, aren't we? So we know that there's going to be a factor of 8n in the nth term. So let's have a look. We've got 8n plus 3 or 8n minus 5. So let's say the first term is 1. So we're going to do 1 times 8 plus 3. We're testing out this one now. Let's see if that works. What's 1 times 8 plus 3? We're going to get 11. So that can't be right. So let's try this one. So 8n minus 5. So we're going to do 8 times 1 minus 5. And that gives us 3. So because this is 3, and 3 is the first term, that means this must be the correct nth term. Question 4. Work out the lowest common multiple of 20, 30 and 40. Circle your answer. Okay, so lowest common multiple. So we want a number which can divide by 20, 30 and 40, and we want the lowest one. So let's try 10. So can we divide 10 by 20? No, we can't, so we know 10 isn't the answer. What about 120? Can we divide 120 by 20? Yes, that will give us 6. Can we divide 120 by 30? Yes, that will give us 40, so that's right. Can we divide 120 by 40? Yes, that will give us 3. So 120 can be divisible by 20, 30 and 40. And because it's the smallest number left, we know that this will be the lowest common multiple. Okay, question 5. The length of a table is 110 centimeters to the nearest centimeter. Complete the error interval table. So the length is 110, so that goes in the middle. And we want to find out the lowest and the highest values, which will round to 110. So we've got 2 slightly different signs here. We've got less than or equal to, or bigger than. So the smallest size, which will round up to 110, is going to be 109.5. And then the biggest length, which will round down to 110, is going to be 110.5. So for this one, imagine you measured your table to be 110.5. We want it to be less than this. So this will round down to 110 because of this less than symbol. And on the right, imagine our table, we measure it to be 109.5 centimeters. Because it's bigger than or equal to 109, that's going to round up to 110. Question 6. A music festival has taken place each year from 2011. The table shows the number of people who attended each year. So year, here, number of people. The festival organisers draw a time series graph to represent the data. The first 4 years have been plotted. Okay, 6a, complete the graph. So let's see, we've got 2011, 2012, 2013, 2014. So we want to put 2015, 2016, 2017, 2018. So that is this data here. We want to put this data into the graph. So let's do 2015. So in 2015 they had 2,023 people. So 2015 is here, so we're going to go up to 2023, which is about here. And then the next one is 2016, and they had 2,612 people. So go 2016, go up to 2,612, which is about here. 2017 they had 3,251, so 2017 go up to 3,251 about here. Last one, 2018, it's 3,780, so find 2018 and then go to 3,780, which looks about right. And now we need to join these with a straight line. So I'm just doing it by hand, but in the exam you need to use a ruler because there's marks for accuracy. Okay, so that's 6A done for your 2 marks. Okay, 6B, use the graph to estimate the number of people who will attend the festival in 2019. Okay, so what we can do here is we can draw a line off best fit, or we can just see that it's trending upwards. So we're going to carry on this line here, and we're going to keep drawing a straight line up like this. And then we're going to write 2019 on our graph. We're going to go up to this point here, and then we're going to go across, and we can see that about 4,500 people will attend. So that's our answer, 4,500 people, and this is an estimate. So they want to see this little bit drawn onto your graph. Okay, that's it for question 6. Okay, question 7. We are given k equals n squared plus 9n plus 1. Mo says k will be a prime number for all integer values of n from 1 to 9. Show that Mo is wrong. You must show that your value of k is not prime. Okay, so we want to prove him wrong. So we want to say that we can get a k that is not a prime number. Okay, so we're going to find all the values of k. So let's make a table. So let's say n, and let's have k. So if n is 1, what will k be? So you're going to substitute 1 into here. So you're going to get 1 squared plus 9 times 1 plus 1. Okay? And then we're going to do this for all your values of n. Okay, so because this is a calculator exam, you can do that. I'm going to pause the video and fill it in. Okay, so I found out all the values of k. So we want to show that at least one of these is not a prime number. So let's look at 11. So 11, is 11 prime, yes or no? So we can say yes, 11 is prime. Okay, so we just need to know that from knowledge of numbers. 23 is also prime, 37 prime, 53 prime, 71 prime, 91. Okay, this is the one we're looking for. 91 is not prime. How do we know that? Okay, so 91 over 13. This will give us a integer which proves that it's not prime. So 91 over 13 equals 7. So we can split 91 into 13 times 7. Therefore, 91 is not prime. Done. Okay, question 8. Doug owes an amount of £600. He wants to pay this amount off in 5 months. He says, each month I will pay back 20% of the amount I still owe. Show working to check if his method is correct. Okay, so let's split this up into every month. So for the first month, how much does he owe? So he starts with 600. Okay, and he's going to pay back 20% of this. So what is 20% of 600? 20% of 600 is 600 times 0.2, which will give you 120. Okay, so he pays back £120 in the first month. So in the second month, let's call it 2M for second month, he's going to have 600 minus 120 left. So what's 600 minus 120? It's 480. So he's got £480 left. And now we need to do 20% off 480. And that's going to be the amount he pays back for the next month. So 480 times 0.2 gives you 96. Okay, so 96 is what he pays off in the second month. So now for the third month, let's write 3m. We can write, we know he's going to have 480 minus 96. That's how much he's got left. Okay, so 384 is what he's got left. So 20% off 384 is going to be 384 times 0.2. And now he's left with 76.8. And now, month 4, he's going to have 384 minus 76.8, which gives you 307.2. Now 20% of this is what? 20% is times by 0.2. You're going to get 61.44. That's how much he pays off this month. So for the final one, the 5th month, we're going to do 307.2 minus 61.44, and that gives you 254.76. Okay, so last one, 20% of this is what? So we need to times that by 0.2 and then subtract. So you're left with 49.152, and then after 5 months he will have paid off, this is the last one, 254.76 minus 49.152. Okay, so let's put that into the calculator. 254.76 minus 49.152, and that gives you 205.608. So this is the amount he still owes. So we can say still owes money. So his method is not correct, so we should put that. So method not correct. And he still owes money after 5 months. Okay, that's it. Question 8 done. Question 9. A motor racing circuit consists of 2 parallel straight sections, each of length 0.75, a semicircle of diameter 0.9 kilometers, 3 equal smaller semicircles. Okay, the length of the motor race must be greater than 305 kilometers. What is the lowest number of full laps needed at this circuit? You must show your working. Okay, so we want to find the circumference of this shape. So we need to find the length of 1 lap. Okay, so 1 lap is going to be equal to this circumference. So we can do the straight line bits first. So we know this bit and this bit. So that's going to be 0.75 plus 0.75. And now we want to have this bit here. So this bit is going to be half a semicircle. So what's the circumference of the semicircle? It is diameter times pi. But this is only half a semicircle, so we're going to put it over 2. So the diameter is 0.9, so we can do 0.9 pi over 2. Okay, now we need to add these bits. So we've got 3 semicircles. What's the diameter of these semicircles? So each one of these will be how long? So these two are parallel, so we know if this whole distance is 0.9, this little distance is going to be 0.3. So we've got 3 semicircles, haven't we? So we're going to use this formula again, and we know this time our diameter is going to be 0.3. So we can put 0.3 pi over 2. So now we can work out what 1 lap equals. So get your calculator out and put it in. So 0.75 plus 0.75 plus, now you've got to use the fractions, 0.9 pi over 2 plus 3 lots of 0.3 pi over 2. Okay, your calculator will either give you an answer with pi or without pi. Mine's given me one without. So I've got 4.33 kilometers. And now this is the distance for one lap. So now we want to divide the total distance of the race by the length of one lap. So total distance over one lap. So we're going to get the total distance we want to be 305, and now the length of one lap is going to be 4.33. So 305 divided by 4.33 gives us 70.4 laps. So 70.4 laps will be exactly 305 kilometers. But we need to do full laps. So we can't just end the race on 70.4 laps. We need to finish the lap. So we need to add, well, we just need to finish the lap, don't we? So instead of 70.4 laps, we're going to drive all the way to the start finish line. So your answer is going to be 71 laps. And that is question 9 done. Okay, question 10. Solve this inequality. So we've got 8 is bigger than 3 minus a half x. Alright, so let's think about what we can do. So let's get this 3 to the other side. So let's say we're going to have 8 minus 3. So we're going to get 5 is bigger than minus half x. Now we're going to times by minus 1. Actually no, we're going to times by 2 first. So we're going to get 10 is bigger than minus x. And now we're going to multiply by minus 1. Now multiplying by minus 1 will flip the inequality sign. So we're going to get minus 10 is smaller than x. And that's your answer. Minus 10 smaller than x. Done. Alright, question 11. Use trig to work out the size of angle x. So angle x is this one here. So for this one we need to recall our trig knowledge. So do you remember SO, CA, TOA? Okay, so we want to label our sides in relation to our x angle. So this one here is the opposite side, so that's going to be called O. The 10 centimeter side is the longest, so that's the hypotenuse. 9 centimeters is next to x, so it is adjacent. So what do we have? We know h, we know a. So which one of these has h and a? It's this one, isn't it? Cos. So we know the cos of x is going to be equal to adjacent over hypotenuse, which is 9 over 10. Because here's our a, here's our h, a, h. So we've subbed those into here. So now we need to do some rearranging. So we know x is going to be equal to inverse of cos, cos minus 1, over 9 over 10. So now get your calculator, be careful, make sure you use the right function, inverse cos, not regular cos, of 9 over 10. And you should get 25.84. 25.84. And that is question 11 done. 25.84 degrees. Okay, 12. Lewis wants to draw the graph y equals x cubed from the values of x from minus 2 to 2. Here is his graph. Make one criticism of his graph. Okay, Lewis, we're going to keep this civil and just give you one criticism like it wants. Okay, so you've plotted these points, but what you've done is you've plotted them with a straight line. So what we could say is perhaps you should use a smooth line to join them. Okay, so that's our one criticism. Use a smooth line. What else could we say? We could say you could take more x values. Let's just give some more criticisms. In the real exam, only give one, but I'm going to give you a few. So, more x values. Okay, 2 criticisms. That's question 12 done. Question 13. The probability of heads when a biased coin is thrown is 0.6. The coin is thrown 500 times. Circle the expected number of tails. Okay, so this is a bit of a trick question. So it says the probability of heads when a biased coin is thrown is 0.6. So the probability of getting a tails is not 0.6, it's going to be 1 minus 0.6, so that's going to be 0.4. So if the coin is thrown 500 times, how many times are we going to get a tails? So we're going to do 500 times 0.4, that should give you 200. Done. Question 14. The mean mass of a squad of 19 hockey players is 82 kilograms. A player of mass 93 kilograms joins the squad. Work out the mean mass of the squad now. Okay, so this is going to be total weight, so the weight of everyone divided by how many people. So what is the total weight of the team? So we know 19 of these players are 82 kilograms. So we're going to do 19 times 82. So this is the 19 players we've already got. And then we're going to add one more. So we need to add 93. And then we need to divide it all by how many players. So there were 19, and now we've added one more. So now we've got 20 players. So put this into your calculator. So 19 times 82 plus 93 divided by 20 should give you 82.55. And that is 14 done. Okay, question 15. A company makes two types of lampshade using fabric on wireframes, Lampshade A and Lampshade B. Okay, let's look at A. Fabric is used to make the curved surface of a cylinder. The cylinder has radius 8 centimeters and height 22 centimeters. Okay, so let me do a crude little drawing to try to visualize what we're doing here. So we only care about the curved surface. We only care about this bit here. We don't care about the top, and we don't care about the bottom because there's no fabric there. Okay, so let's try to work out the surface area of the bit we care about. So we need to work out the circumference of this circle, don't we? So what is the circumference of a circle? So we know the circumference C is equal to pi times the diameter. Okay, so what is the circumference? We know 8 centimeters is the radius, so we're going to double that to get our diameter, which is going to be 16. Okay, so we're going to do 16 times pi, and that's going to equal C, which is our circumference. So we're going to do 16 times pi. So 16 times pi equals 50.2654. We're just going to write 50.27 to 2 decimal places. Okay, so that is the circumference, and now we need to multiply that by the height. So we're going to do 50.27 times by 22. And that's going to give us, let's see, 1105, sorry, that's 1105.84. Okay, so this is the total surface area of the fabric for lampshade A. So let's write surface area. Okay, let's move on to lampshade B. Fabric is used to make the 4 triangular faces of a pyramid. Each triangular face has the base 15 centimeters and a perpendicular height of 24 centimeters. Alright, so let's have a think about this. We want to work out the area of 4 of these triangles because there's 4 faces, 1, 2, 3, 4. So we want to work out the area of 4 of these triangles. Okay, let's do some rearranging. So how about we put this here? So we can rearrange this into a square, can't we? So we're going to get a square of 24 high and 7.5 wide. So we're going to do 24 times 7.5, which is going to give us 24 times 7.5 is 180. And now we've got to account for the fact that we have 4 of them. So we can do 180 times 4 gives us 720. Okay, so 720 is the surface area of B. And then we had the surface area of A up here. Okay, so let's look onto the other page. So we know the cost of the fabric is going to be £400 per square metre. Other costs for A is going to be £3.50. Other costs for B is going to be £7.50. So we need to look at the cost of each lampshade separately. So let's do lamp A first. So let's work out the cost of the fabric. So we know the area of the fabric is going to be what we worked out earlier. So it's going to be 1105.84 times by the cost per square metre. So we know it's times by 400. But what do we need to do? The price is given in square metres, but we're not working in that. We're working in centimetres squared, aren't we? So how do we convert square centimetres to square metres? So let's pretend we had a square metre, right? So 1 metre, 1 metre. But if we wrote it in centimetres, it would be 100 and 100. So how many square centimetres are in 1 square metre? So we need to divide this one by 10,000, because 100 times 100 equals 10,000. Okay, so once we've divided it by 10,000, we can put that all into our calculator. So we can do 1105.84 divided by 10,000 times 400 gives you 44.23. And now that's the cost of just the fabric. So now we need to add the other costs for A. So we need to do 44.23 plus £3.50. And that's going to give you 47.7. 47.7. So that's the total cost of lamp A. So now we're going to do the same for lamp B. So we're going to take our total amount of fabric, which was down here, so that was 720 over 10,000 plus the other cost. Whoops, no, we've got times by 400 first to get the cost of the fabric. So put that in, so you're going to get 720 divided by 10,000 times by 400 gives you 28.8. So 28.8, and now we need to add the other costs, which are up here. So we need to add 750 to this. So 28.8 plus 7.5 equals 36.3. So now we've got the cost of lamp A and lamp B. But the question wants your answer in the form n.1 as a ratio. So let's write the cost of lampshade A. So lampshade A, the total cost was 47.7, and the total cost of lamp B was 36.3, and we want to get lamp B, we want to get that to equal 1. So we can divide the whole thing by 36.3, and if we do that, the right hand side will go to 1, and we also need to work out what the left hand side will go to. So 47.7 divided by 36.3, and we should get 1.31 to 1, and that's our answer, 1.31 to 1. Okay, lots of work for 5 marks, but we got through it. Question 16. In a running club there are 50 females and 80 males. If a female is chosen at random, the probability she has blue eyes is 0.38. If a male is chosen at random, the probability he has blue eyes is 0.6. One person is chosen at random. Show that the probability the person has blue eyes is more than 0.5. Okay, how can we do this? Okay, so we can draw a tree diagram to help us solve this. So let's start here. So we're going to either have males or females, aren't we? So let's do females at the top, males at the bottom. So what is the probability of choosing a female? Well, there's 50 females and 80 males, so in total there's 130 people. So the probability of picking a female is going to be 50 over 130. And conversely, the probability of picking a male is going to be 80 over 130. Okay, so if we've chosen the female, what then is the probability of her having blue eyes? So let's put a B for blue, NB for not blue. So it says the probability she has blue eyes is 0.38. So we can put 0.38 here, and then the probability of her not having blue eyes is going to be 1 minus 0.38. So that's going to be 0.62. And then let's do the same for the males. So we've got blue, not blue. So the probability he has blue eyes is 0.6, so we can put that here, 0.6. Probability of not blue is going to be 0.4. Okay, so we want to show that the probability the person has blue eyes is more than 0.5. So we want to care about this one, blue, this one, blue. So when we've got a tree diagram, we multiply across and then add down. So we're going to do 50 over 130 times by 0.38, and then we're going to do this one here because we care about blue eyes. We're going to do 80 over 130 times by 0.6, and then we're going to add these two answers together. So first one, 50 divided by 130 times by 0.38, you get 19 over 130. Okay, 19 over 130. Then the second one, you can do 80 divided by 130 times by 0.6. Gives you it gives you 24 over 65. 24 over 65. Now we're adding these two together. So 19 over 130 plus 24 over 65. Okay, let's see what we get. Plus 19 over 130 gives you 67 over 130, and this as a decimal is 0.515. So this is bigger than 0.5. So that has proven what the question wanted. Okay, done for question 16. Okay, question 17. W equals 3 over 5 times square root of x. Circle the expression for w squared. Alright, let's write this out. So w squared is going to equal this 3 over 5 root x squared, which is the same as timesing it by itself. So it's going to be 3 over 5 root x times by 3 over 5 root x. So multiplying fractions, do the top then do the bottom. So you can get 9 over 5 times 5 is 25. So root of x times root of x is x. So you're going to get 9 over 25x, which is this one. Done. Okay, 18. Here is some information about the ages of people at a concert, where you've got the age and the frequency. So age, frequency. Draw a histogram to represent the information. Okay, histograms you want to find the frequency density. So to do that, you need to find the width and then do the width divided by the frequency. So let's write down the width. Well, it's not really the width, is it? But for this it helps.
Here's what I found.
So the width of this one is going to be 15 minus 10, so that's going to be 5. The next one is going to be 25 minus 15, which is 10. Next one is going to be 15. Next one is going to be 30. Okay, so now we want to find out the frequency density. So that is going to be the frequency divided by the width. Okay, so the first one is going to be 8 divided by 5. So 8 divided by 5 gives you 1.6. Okay, next one is going to be 24 divided by 10, which gives you 2.4. So 24 divided by 10 gives you 2.4. Next one is 30 divided by 15, gives you 2. The next one, 39 divided by 30. Put it in your calculator, you should get 1.3. Okay, so now we can fill this in. So let's fill in this first one first. So between 10 and 15, which is here, down the bottom, what is the frequency density? So frequency density is this column we've worked out. So the first one, the frequency density is 1.6. So we need to go all the way up to 1.6, which is here. Okay, make sure you draw it nicer than I am. You get marks for accuracy. So the next one, the frequency density is 2.4 between 15 and 25. So 15 is here, 25 is here, and the density is 2.4. So we need to go up all the way to 2.4, which is here, and then go down. Okay, the next one, 25 to 40, frequency density of 2. So 25 to 40, frequency density of 2, so you go up to 2, and it's done. Okay, the last one, 40 to 70. So 40 here, 70 here, we're going up to 1.3. So start here, all the way up to 1.3. Like I say, use a ruler in your exam. Okay, so that is it for question 18. Okay, question 19. The length of a roll of ribbon is 30 meters. Correct to the nearest half meter. A piece of length 5.8 meters, correct to the nearest 10 centimeters, is cut from the roll. Work out the maximum possible length of ribbon left on the roll. Okay, so we want the maximum possible length of ribbon left on the roll, which means we want to maximize the length of the roll. Okay, so let's see. So max length of roll is going to be what? So it says the length of the roll of ribbon is 30 meters, correct to the nearest half meter. So if it's correct to the nearest half meter, so half meter is 0.5, that means the biggest it can be is going to be 30.25 meters. Okay, so we've maximized the length of the roll. Now we want to minimize. What do we want to do? We want to minimize the piece cut off. So let's see, min cut piece. So this is going to be 5.8, correct to the nearest 10 centimeters. So this is going to be 5.75. And now all we want to do is 30.25 minus 5.75. And that's going to be our answer. So 30.25 minus 5.75 should give you 24.5. And we are done. Okay, question 20. Curve P has equation y equals 2 times x minus 1 squared minus 5. Curve Q is a reflection in the y-axis of curve P. Work out the equation for curve Q. Okay, so a reflection in y. When we do this, we replace x with negative x. So what we're going to do is change this x into a minus x and then rearrange to get it in this form. So we can say y equals 2 negative x minus 1 all squared minus 5. And now we just need to do some rearranging. So let's see, 2 minus x minus 1, and we're squaring that, so we're timesing it by itself. So minus x minus 1 minus 5. So let's multiply out these brackets here. So you're going to get 2 minus x times minus x is going to give you an x. Minus x times minus 1 is going to give you a plus x. Sorry, I've missed an x squared here, haven't I? Then we can get plus x plus 1 minus 5. So this is going to be 2x squared. Now we've got two x's in here, so that's going to be 2 times 2, which is going to give you 4x plus 2 minus 5. So your answer is going to be 2x squared plus 4x minus 3. And we are done. Okay, 21. Priya and Joe travel the same 16.8 kilometer route. Priya starts at 9 AM and walks at a constant speed of 6 kilometers an hour. Joe starts at 9:30 AM and runs at a constant speed. Joe overtakes Priya at 10:20 AM. Okay, let's have a look. At what time does Joe finish the route? So, we know that speed equals distance over time. So what do we know about Priya? So we know, do we know her speed? We do know her speed, so we know S equals 6 kilometers. We know the distance, which is 16.8, but we don't know the time. So we know her speed is 6 kilometers an hour. We know the distance, which is 16.8, and we don't know the time. Okay, so let's rearrange this to make t the subject. So we're going to get t is equal to 16.8 over 6. Put that in your calculator, you're going to get 16.8 divided by 6 gives you 2.8. 2.8. So what is this 2.8? That is a time, and we're working in hours. That's 2.8 hours. That seems about right, doesn't it? Okay, so it takes her 2.8 hours to walk 16.8 kilometers. Okay, so let's think about what else we know. We know Joe, and we know he overtakes Priya at 10:20. So we want to find out how far Priya has travelled at this time. So let's talk about Priya some more. Priya is going at 6 kilometers an hour, and we want to find out where she is at 10:20. So from 9 AM to 10:20 is 80 minutes. Or let's keep it in hours because that's what we're working in up here. That is equal to 4 over 3 hours, or an hour and 20 minutes. So after 4 1/3 hours, we want to work out her distance, don't we? And we've got a time and we've got a speed. So let's use speed equals distance over time, and we can substitute in her speed of 6 kilometers an hour. We don't know her distance, which is what we want to find out, but we do know her time, which is 4 over 3. And let's rearrange this to get distance. So we're going to get 6 times, we've brought everything up, haven't we? 6 times 4 over 3 is going to give us what? 6 times 4 over 3. 6 times 4 over 3 is, let's see, 8. 8. That's a nice round number. So let's write down what we've worked out so far. So at 10:20, Priya walked 8 kilometers. At 10:20, Priya walked 8 kilometers. Okay, so they're traveling the same route. So Joe starts at 9:30 and he's getting 8 kilometers into his run. So let's look at Joe now. So he goes from 9:30 to 10:20 because they meet at the same point. So he's got 50 mins. So let's put that into hours. What is that in hours? That'll be 5/6 of an hour. So we know his time. So his time for Joe is 5/6. Do we know his distance? We do. His distance is going to be the same as Priya's distance, which was 8. So we've got time, we've got distance, we don't have speed. So let's substitute it in. So speed equals distance over time. We know the distance, we know the time. So Speed equals distance over time. S equals 8 over 5/6. S is going to equal what? Speed. Do we even need to know his speed? Oh, we do. So let's find his speed first. So 8 divided by 5/6 is what? Put it into calculator. I have got his speed to be 9.6 kilometers per hour. Okay, so this is Joe's speed. And now we want to know what time does Joe finish the route. So the route is 16.8 kilometers and we know his speed. Now we can find out the time. So speed equals distance over time. So his speed is 9.6. We know the distance is 16.8. And now we can work out the time. So that means t is equal to 16.8 over 9.6. Put that in your calculator. And I have got 7 over 4. Okay, so this is his time. The time to run the whole course, which is 16.8 kilometers. So he takes, let's convert this into hours, or hours and minutes. So this is 7 over 4 hours, which is the same as 1 hour and 45 minutes. Okay, but it's what time does he finish the route? So he starts the route at 9:30, so it's going to be 9:30 plus an hour and 45 minutes. So what would this be? So it'll be 10:30, 11, it'll be 11:15. Done. We are done. Just be careful when you're adding minutes. Okay? Just be a bit careful. Okay, we are done. Question 22. An approximate solution to an equation is found using this iterative formula. xn plus 1 equals xn cubed minus 2 over 10, with x1 is equal to minus 1. So work out the values of x2 and x3. So for this one, all we're doing is substituting x1 into here. So x2 is going to be equal to minus 1, because we put minus 1 into here, minus 1 cubed minus 2 over 10. Minus 1 cubed is minus 1, so it's minus 1 minus 2, so that's minus 3 over 10, and that is x2. So minus 3 over 10 equals x2. Now to find x3, let's write down x2 first, so minus 3 over 10. Okay, x3 is going to be equal to x2, but we've got to substitute x2 into here. So let's see, so minus 3 over 10, all cubed, minus 2 over 10. Okay, put that into your calculator. So we're going to get, this is a bit of a complex one to put in actually, so minus 3 over 10, all to the power of 3, minus 2 over 10. And I have got minus 0.2027. So that is x3, minus 0.2027. You could also leave it as a fraction if you want, which would be minus 2027 over 10,000. Okay, done. Okay, 22b. Work out the solution to 5 decimal places. Okay, so for this one, what we can do is we're just going to substitute x3 in to find x4. So x4 is going to be equal to x3 substituted in. So we can do 0.2027 over 10, but don't forget to cube it, and to subtract 2. Okay, so let's put this in. What are we going to get this time? So put a bracket around your minus. So you're going to get 0.2027 all cubed minus 2 over 10. And you should get minus 0.200832 8 dot 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 dot. But we want it to 5 decimal places, so 1, 2, 3, 4, 5. So we're going to write minus 0.20083 to 5 decimal places, and we are done. Okay, question 23. The diagram shows the side view of a step ladder with a horizontal strut of length 48. The strut is 1/3 of the way up the ladder. The symmetrical cross-section of the ladder shows two similar triangles. Work out the vertical height h of the ladder. Okay, so this is a triangle problem. So let's put this height down the middle, because that's where it's going to be. So we want to find this h for the height. So let's try to figure this out. So we have two similar triangles. Okay, so now we've labelled that, we can also label this distance here. This is going to be half, isn't it? So that's going to be 24. So the important sentence in this question is the strut is 1/3 of the way up the ladder. So this is 1/3, and then this one from here to here is going to be 2/3. So what we can do now is we can make a triangle, a right angle triangle. So we know this one is going to be 24. We know this one from here to here is going to be 141. Actually no, let's do the big triangle. So we're going to change this. Instead of 24, this is going to be 141, and then we can work out the bottom length. So if it was 24 here and it's 2/3 along, when you get to the bottom it's going to be 3/3 along, isn't it? So it's going to be 24 times by 24 divided by 2 times 3. No, it's not. It's going to be 24 times 3 all over 2 to get the whole distance. So let's see. 24 times 3 over 2. 24 times 3 divided by 2 gives you 36. So this bottom length is going to be 36, and now we want to work out the height. So that's a squared plus b squared equals c squared. Use Pythagoras. We know c and we know a. So let's substitute them in. So we've got 36 squared plus b squared, which we don't know, equals 141 squared. So how can we work this out? So we know b squared is going to be equal to 141 squared minus 36 squared. Therefore b is going to be equal to 141 squared minus 36 squared. And now b is equal to h, because that's what we want to find. So put it into your calculator. Square root of 141 squared, excuse my typo, minus 36 squared, and that should give you 136.3. 136.3. And we are done. Okay, question 24. We are given the volume of a sphere. A sphere is 4/3 pi r cubed, where r is the radius, and the volume of a cone is 1/3 pi r squared times h, where r is the radius and h is the perpendicular height. So let's just draw that out. So for the cone, this is going to be the height. Okay, a sphere has radius 2x centimeters, a cone has radius 3x centimeters, and a perpendicular height of h centimeters. The sphere and the cone have the same volume. Work out the radius of the cone and the perpendicular height of the cone and give your answer as a ratio. Okay, so we have two formulas and we want to give the answer as a ratio. Okay, so let's try to find out h. So we've got two equations and we know the volumes are the same, so we can set them equal to each other. So 4 over 3 pi r cubed is equal to the volume of the cone, which is a third pi r squared h. Okay, so the sphere has a radius of 2x centimeters, so we can substitute that in, and the cone has a radius of 3x centimeters, so we can substitute that in. So we're going to get 4 over 3 pi times the radius of the sphere, which was 2x. So times by 2x cubed is equal to 1/3 of pi times the radius of the cone. And the radius is here, 3x squared times by h. So can we rearrange this to get the, well, what are we trying to work out? We're trying to work out the radius of the cone and the perpendicular height of the cone. So let's try to rearrange this to make it more simple. So let's try to get h on its own. So let's move everything to one side. Well, let's simplify first. So we're going to get 4 over 3 pi times by 2x cubed, which is going to be 8x cubed equals 1/3 pi times by 3x squared. Okay, I've made a little mistake here. That square should be on the outside. So we're going to get 6. Are we? No, we're not. We're going to get 3 times 3 is 9. So we're going to get 9x squared times by h. So let's do some more simplifying. 4 times 8 is 32 over 3. So we're going to get 32 over 3 pi x cubed is equal to, we can simplify this, so we can get 3 pi x squared h. And now let's move everything onto one side. So we're going to get h is equal to 32 over 3, but this 3 is going to be divided, so it's going to be 32 over 9 pi x cubed. So we've moved this 3 over, you can move this pi over, x squared, and then what can we simplify? 32 over 9 doesn't simplify at all, and now we've got 2 pi's which will cancel out, and we've got x cubed over x squared, so that will just leave us with an x. Okay, so now we found h to x. So let's just rearrange this a little bit so we can see the ratio better. So let's move x to the other side. So we're going to divide 3 by x. So we're going to get h over x is equal to 32 over 9. And now we're almost done. But the question says we want to find 3x because the radius is 3x. So we need to multiply the bottom by, well, we need to change the x into 3x. So we're going to get h over 3x is equal to 32 over 27. And now let's just write this as a ratio. So we're going to get 32 dot dot 27, and we are done. Okay, so we need to swap these around because it wanted them in the other direction. It wanted a to be the radius of the cone, which was 27, so it should be 27, 32, just to be perfect. Alright, we are done. Okay, question 25. ABCD is a quadrilateral. The quadrilateral is reflected in the line x equals 4. Which vertices are invariant? Okay, invariant means stays the same. Okay, so which ones stay the same when you reflect in x equals 4? So let's find x equals 4. So that will be this line here. So we're going to end up with a sort of shape like this. So which one of these points stay the same when you reflect the shape? So you can look at it and see B and C will not move, whereas D will go to here, A will go to here, but B and C will stay in the same place. So those two are invariant. So you need to remember the definitions of these words, because I had to Google that. Alright, 25 is done. Okay, 26. We've got a function f of x is equal to 2x plus 3 over x minus 4. Work out f inverse x. Alright, so this is just a case of rearranging. So what we're going to do is we're going to say y equals 2x plus 3 over x minus 4. And now we want to rearrange this to get x as the subject. So we're going to multiply through by x minus 4. So we're going to get y equals x minus 4. No, we're not. We're going to get y times x minus 4 is equal to 2x plus 3. Multiply out, we're going to get y x minus 4y equals 2x plus 3. Remember what we're trying to do. We're trying to get x on its own. So let's see what we can do here. Let's keep... Okay, so let's try to get all the x's onto one side. So we're going to swap this 4y and this 2x. So we're going to get yx minus 2x is equal to 3 plus 4y. And now we're going to factorize the x out of this. So we're going to get x is x times y minus 2 is equal to 3 plus 4y. Then bring the y over 2 to the other side. So x equals 3 plus 4y over y minus 2. Okay, so now we've rearranged it to get x as the subject. So now we need to write the answer properly. So we need to write f inverse of x is equal to 3 plus 4. Okay, it's a function of x. So even though we've got a y here, we need to change this to an x in our final answer. So we've got 3 plus 4x over x minus 2. And that's it for 26. Okay, question 27. So we've got the line y equals 3x plus p and the circle x squared plus y squared equals 53. And they intersect at the points a and b. And p is a positive integer. So, show that the x coordinates of a and b satisfy the equation blah blah blah. So we want to get this and this into this. So, a point of intersection is a point where they cross. So what we can do is we can put this into here. So we know y equals 3x plus p, so we're just going to substitute this as your y into here. So we're going to get x squared plus 3x plus p squared equals 53. So now we're going to multiply out, we're going to get x squared plus, well, we're going to do 3x plus p times by 3x plus p equals 53. X squared plus, now we're just multiplying out this bracket, so 3x times 3x, you can get 9x squared. Then 3x times p, you can get 3xp. Then you're going to get the same thing on the other side. So you're going to get plus 3xp. And lastly, you're going to get p times p. It's going to give you p squared equals 53. Now let's do some simplifying. X squared plus 9x squared plus 3xp plus 3xp. That goes together, so you're going to get 6xp plus p squared equals 53. And we can put these two together, which will give you 10x squared plus 6xp plus p squared. Move the 53 to the other side, minus 53 equals 0, which is exactly what they wanted. Okay, 27b. The coordinates of A are 2, 7. Work out the coordinates of B. You must show your working. Okay, so we have two equations of x and y, and we want to find the unknown p. So let's write that out first. So we know y equals 3x plus p. So what do we want to do? Let's use the coordinates of A to find out p. So we can substitute these into here, where x is 2 and y equals 7. So this is going to give us 7 equals 3 times 2 plus p. And solving this for p is going to give us p equals 1. So you're just going to get 6 here and then move it to the other side. So now we know p equals 1, we can substitute this into our big equation we're given over here. And then we'll have an equation which tells you the points of A and B. Okay, so let's substitute p in. So we're going to get 10x squared plus 6, and p is 1, so plus 6x plus p squared, which was 1, because p is 1, so 1 squared is 1, minus 53. So plus 1 minus 53. So that will give you minus 52 is equal to 0. Okay, so now we've got a quadratic, and we can solve this to find x. So let's see if we can simplify this at all first. So can we divide through by anything? Can we divide through by 4? Can we divide through by 2? We can divide through by 2, can't we? So we can simplify this to 5x squared plus 3x minus whatever 52 divided by 2 is, so minus 26 equals 0. Okay, so we've got still a difficult quadratic to solve. So to do these when the leading coefficient isn't 1, we have a different method. So this method requires finding AC and B. So in our case, what is AC? AC is going to be 5 times minus 26, which is going to give us 230? No, minus 130. And then B is going to be 3. So we want to find two numbers which multiply together to give us 130 and add together to give us 3. So what are the factors of 130? So 130 can be divided by, oh, that was quite simple actually. 130, we can get 130 by doing 13 times 10. So that means our factors are going to be 13 and 10. So we want to change this plus 3 into, we want to split it down the middle. So instead of writing plus 3, we're going to write 5x squared plus 13x minus 10x minus 26 equals 0. So what we've done here is we've just changed this middle one. We've changed the 3x into a plus 13x and a minus 10x. So we've just made it a bit more complex for now, but it will help. So let's rewrite it. So let's swap these two around. So we're going to write it as 5x squared minus 10x plus 13x minus 26 equals 0. So now we can factorize each side. That's why I moved them, because 13 and 26 go together nicely and 5 and 10 go together nicely. So on this side here, what can we take out? We can take out 5x. So we can say 5x times x minus 5. So that is that side factorized, and on the other side we've got 13x minus 26. We can take out a 13, can't we? And then we're going to be left with x minus 2. Yeah, so we've got x minus 2 there, and that's all equal to 0. I've made a mistake on this side, haven't I? That should be a 2. So it's x minus 2. So there we go, we've got our two factors. So this is one of our factors, x minus 2. So we can write that, x minus 2, and then the other factor is going to be this 5x and this 13. So we're going to get 5x plus 13. So we've got one of our values of x is going to be here. So that value of x is going to be x equals 2. And then this value of x is going to be, well, let's write it out. So we've got 5x plus 13 equals 0, which will imply that x is going to be equal to minus 13 over 5, which is minus 2.6. So our x value is minus 2.6. So this is our x. So now we need to substitute this back into our formula to find y. So we can put this in either of these. So which one should we use? We found the equation with p, didn't we? So we can use this one actually. So y equals 3x plus 1. We know x is minus 2.6, so y is equal to 3 times minus 2.6 plus 1. So let's put that in the calculator. 3 times minus 2.6 plus 1 is equal to minus 6.8 6.8. So that is your y value. So x is 2.6 and y is minus 6.8. And we are done for 27b. Okay, question 28, last question. Here is a sketch of a quadratic curve. The turning point is 3, minus 2. Circle the correct statement about the gradient of the curve for x is less than 3. Okay, so x is less than 3. So we want the gradient on any point on this side. So what is happening on this side? Is it going up or is it going down? So we should say you travel this way along the graph. So these arrows are bad. So is it going down or is it going up? So it's going down, 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 then it gets to the turning point and then it starts going up, doesn't it? So what's happening on this side here? So is it going down or is it going up? It is going down, isn't it? So the gradient here is negative because negative gradient means it's going down. Okay, that's it for 28 and the exam is finished.